Hi, this is Scott with Mr. Robot Electronics. Today I'm going to show you how to make a customized, panelized version of your circuit boards in EasyEDA. So let's say I have this design here, which I do. It's a digital clock replacement chip for Heathkit brand clocks. And this is the design. I've had it built before. And this is my layout. I'll show you just the top layers, and that is it has my logo and my silk screen on there. Let's say I have a customer who wants to build some of these to sell, and they want their own logo on them. So let's call that company H Corp. Okay, and when I build these, you normally panelize them into 15 boards per panel, and then I order 5 boards. So I get 75 boards total. But I want to get some boards for myself and some for them. So how do you do that? So let's say, for instance, that what I want to do is I want to panelize it like this, where I do each panel has 10 of their boards and 5 of mine. So I'll get to keep some out of their build. The way you do this normally is you would just take under Tools, you go Panelize, and I normally V-cut them. You tell them how many columns you want, so I do 3 columns, 5 rows with V-cuts. You don't need any space between them, and you say Apply. Now, if you turn on the document layer here, you'll see that they create a single copy of this because it would make the file too big if they just did all 15 on there. They show the V-cuts on the document layer, but the important thing is they cut where the board outline is, the purple. That's the board outline. The document layer they ignore. But the problem with this is that you're going to get a panel with all 15 H Corp, and I won't get any. All 5 boards that you order have to be the same. So we're going to forget that. We're going to forget that we did that. We're just going to undo it. And the way you do this is you have to build the panelization yourself. They have no way to put 2 different designs of the same size onto a panel. Now, you could have these boards be completely different designs with as long as the dimensions are the same. So you can get creative there and put a bunch of different designs. You put 15 different designs on a panel, or depending on how big your board is. So the way you have to do it is you create your own. And the instructions are super confusing. They talk about PC board modules, schematic modules. What has to happen is there has to be created a custom reference designator for every component on each of the 15 instances. So what you do is you take your first board, this H Corp logo, you save it as a module, and so this, you just do a save there, okay, and you're done. And then you go back. Actually, what you do now is you go ahead and close that module that you're viewing. In fact, you can even close the H Corp design. I should also mention, I should back up a little, that you run a DRC check on each layout beforehand, and you should get 0 errors, because once you combine them, you can't do a DRC check. So going back to this one, and now I need to create a module for this one. So you just do File, Save as Module, and it just gives it the same name. Okay, now I can close this module view, and it'll look identical to the original one. So I just close this module, and I can close this. I can even close the schematic. I don't need that. Where are the modules stored? They're stored in your library. Okay, there they are. I just had to go back and refresh. So there they are. This is where the modules are stored. So what we do is we're going to cancel out of here for a second. we're going to go back and do a file new PC board. It's going to be a blank PC board. We don't need to set the dimensions. Let's just cancel out of there because it'll dimension itself. And what you do is I can close this additional one. The only thing you need open is the PC board because we're going to pull in copies of the module. And so one of the things to know is that when we do this thing where we say these 10 are going to be H Corp and these are going to be Mr. Robot, we need to make sure that we're going to need to assign numbers, and it'll put a prefix on every component and every net, everything on the entire design so that they're all unique. So when we start building this, the way this seems to work is because of where the origin is located on my board layout. I'm going to place M, then N, J, K, G, H, D, E, A, B of the H Corp, and then I'm going to place O, L, I, F, C of my Mr. Robot. So let's go ahead and start. All you do is you right click, and no, you don't. Well, you can do that. You go to Library, and we're going to want to do the H Corp one first and just say place. And it's going to want to know the prefix letter. So since we're starting in the lower left corner, that would be M. So we'll say, let me move this down a little bit, and I can close this and I can close this to give us a little more room to work. So I just put in H and say OK. Now it doesn't matter where you place this. I'm using my scroll button on my mouse to zoom in. You can place it anywhere. With Snap on the grid, it's really easy. You place it and you center the corner of the board outline on a crossing, and you left click, and that places it, and now it's loading all that information into the PC board layout, and it's prompting you for the next one. Now one thing here, I've got this fill turned on, so what you can do is over here on the right hand side you do copper zone visible, just turn it to invisible, it'll redraw quicker. And I can turn off all these other layers. All you really need is the board outline, and I like to just leave the top silk and top layer on, and that way, and I'm using the scroll button on the mouse to zoom in and out. Okay, and then I use the right click to move left and right. So now we've got one instance placed. So now what we do is the next one we want to place is N in the middle on the bottom because of how the origin is located on there. So we're going to do N and say OK, and instantly it pops out. Now if you accidentally left click and put it in the wrong place, you go, oops, I didn't mean to put it there. Wait for it to draw. You always have to wait for it to draw, and then just undo that. So you've always got an out here too. Okay, so I'm just going to undo that. It's gone. I'm going to just redo that N, and so what I'm doing is zooming in with my mouse scroll button, and you just line up these corners, and it's pretty easy with the snap-on because you can see it gets wider when it's not in the right place. So and then you just left click, and now it's placing that, and you can't really zoom out until it's done placing. Now as you do this, as you add more and more, it's going to get slower and slower as it redraws because the file gets bigger. So now we've got M and N placed. We need to do J and then K. So we just go with J and say J, and I'm going to zoom in here. I can use my right mouse button and hold it to move over so I can center it and see it better. So there you go. And left clicking, and it's go ahead and placing that. So we'll probably zoom through a couple of these on the video here, make it a little quicker for you. But so now we're going to do K. So let's say K. But a lot of people like to watch the whole thing just to make sure. Okay. It's like watching one of those videos where they solder a huge board and it takes like 45 minutes to watch somebody solder. It's like, who wants to watch that? Not me. I like to watch the last 5 minutes when they're plugging it in and it works or doesn't work. Okay, now that it's redrawn, I scroll out. And what I like to do is just right click and move down to where I know the next one's going to be placed, the left corner. Put that in the center. So now I'm going to do G. And there it is. And then I can scroll zoom and quickly align things. And I left clicked and it places that. Can't scroll out until it's done redrawing. So what happens is this whole file is going to be, the Gerber file is going to be 15 times bigger. Okay, because of the you're having individual data for every instance, whereas normally when you panelize only one design, it just does one instance and then they replicate it there at the factory. So H is the next one. Notice it's taking a little longer to redraw now. We have a lot more to deal with. Okay, so here we go. We've got 10. We could just ship it to fab like this, but I want some freebies. I want 5 freebies. So let's go down here to where we're going to place, what's it going to be? See, we're going to put the Mr. Robot ones in the next column. So that's going to be O. So we go back to our library and we select the Mr. Robot logo layout. And these boards are identical except for the silk screen. And then when it's ready, loaded, we say place. And we're going to make this one O. Okay. And that one's going to go on the bottom here. See, so it doesn't really care what design you're putting down. As long as you line them up properly, you're good to go. Next one is going to be L. Okay. And you got to be patient doing this, but it's well worth it because you can get free boards essentially out of a build when you only need so many for a customer. And what did I say? L? L, yeah. Lined up. Next one is going to be I. One of the things that happens with this, because of the fill that I do on the layers, is all the boards short together on the different layers. So even though the nets are unique with their prefix, their letter prefix, you'll get DRC violations. So you don't run a DRC at the end because you've already run DRC on the individual ones. zoom in a little more, line it up perfect, snap baby, snap, there you go. Okay, and it's laying that down. Notice it's a little slower. Now we're going to cancel because this is the last one. And once we're done there, we'll be done. And we can save it, our design. I'll show you how to do that, because we're doing a whole new PC board from modules. Let me show you what I mean by the board layers shorting out. So our copper zone here is copper fill. It's invisible. I've done copper fill, and you'll see, well, actually, I think maybe not. I don't think, maybe they don't short. Okay, I thought they would short between layers, but we'll turn it back off. Okay, so now we're done with our panel. We've created a custom design panel, 15 boards, 5 of them with my Mr. logo, Mr. Robot logo, and 5 with the hypothetical H Corp logo. So now all we do is save, and it takes a while. We're going to save to existing project, come down to where it says project, and go down and find your project you want to save it to. And we give it a title, and that is, we're going to call it MK5017 Rev 3 H Corp build. Okay, and it took a second here to fill in this, but so we go ahead and save that. And it takes quite a while because it's a big file. Okay, now if we go over and expand our side thing here, we can see where we've got, you know what, I forgot to, we just created this is, you hold over the H Corp build. Okay, it's this one. I like to, what I'm going to do is right click on this and modify it and put in the name panelized. So I make sure that's the one I send for fab. Okay, so now it's named panelized. Okay, so now it's been saved. Now what we do is we generate the fabrication files. So there's 3 of these files, the BOM, the bill of materials, the Gerber file for PC board fabrication, and the pick and place. If you're only building PC boards and you're not having them assembled, you only need the Gerber file. So here you say BOM, you export the BOM, and then say export. Now down here it pops up another window. It doesn't pop in front, and you need to find that window, and okay, and then we're going to save it in this folder here. That's the CSV file, and then we just cancel out of those. Then we do the Gerber file. You can check connections, in other words, do a DRC. Yeah, let's do it and see what happens. And you'll see you've got a bunch of, you've got some warnings, I guess. You have one, no DRC errors. Okay, well, that's good. No DRC errors. These warnings are fine. I've checked them before. So let's go ahead again and just say, do the Gerber, and we'll just say no, keep going, and generate the Gerber, because you know these are all good designs. Okay, good. There we go. Okay, so it pops up with this window here, and it says, gives you a little preview of your board and says, hey, you can build 5 boards for only $7.54 plus. So it takes quite a while to build this because it's got a huge, actually it was pretty quick. And again, it pops up a window that's not visible, and you got to go find it at the bottom. So this is a zip file. That's the Gerber file. It contains all the manufacturing data. And the last file is the pick and place file. Export. And again, it doesn't pop up in front. Wish it would, but it doesn't. Okay, so now we've got all of the files here that we need. The if you go in and look at the BOM file, you'll notice that the quantities, like for instance, this part, the 18 mega, it's only got one part per board. You notice the quantity is 15 because it's multiplied that. And look at the prefixes on it. So it's got all of the different prefixes, A, B, C, well, all the different 15 different letter prefixes, and it's done that for all the components. So all the components are unique, so it'll know where to pick and place those. Don't need to save that. We'll get to the Gerber file in a minute. The pick and place file just gives the XY locations. You see the same thing. It prefixes A, B, C, everything all the way down to O. So everything is a unique component, and it counts the components correctly. To check out the Gerber file, there's this wonderful site, JLCDFM Design for Manufacturing tool, and we click Upload. We go navigate to where our Gerber file is. Say Open, and it's loading our file. Take a minute, it's a big file. Okay, so now it's loading our file in. Here you can actually take a look at your files again. It's got the same controls where you can turn layers on and off. You can't turn off the fill for the layers, but you can do a 2D view of your boards. Okay, you can have a look at the top anyway, top layer and bottom layer, and you can do a 3D view. And with the 3D view, you can flip it over like that and look at it. This is without the components. This is just the bare board. So what we do is a DFM check, and it'll check the board to see if there's any manufacturing concerns. Now I've already gone through this with these boards, and so I know everything's okay with it. It'll flag a few things, and I'll point those out and show you what to look for. It looks for things like that are not necessarily caught in the design rules. It'll be more stringent than the design rules. So if you see something that doesn't look quite right, refer to the design rules. So they check things like, okay, trace width, and it says if it's less than 0.1 millimeter danger, between 0.1 and 0.13 it's a warning, and above 0.13 it's good. I use 0.15, so that's good. Everything's good there. And it points out every instance. If you click on an instance, it'll point it out for you. Here's one, annular ring. Okay, so it's saying this is the ring around a hole. So here it's showing, I'm zooming in with my right mouse button. It's saying here's the hole and here's the ring around it. Now it's saying danger because this is less than 0.1 millimeter. The distance between the outside of this pad and the hole is, in my case, 0.05 millimeters, so it's really dangerous. But it says, no, the software may misidentify vias as through holes. So via violations can be ignored. These are all vias, that it's flagging all the vias on my design. So there's a lot of those. And I've gone through and looked at these and said, nope, they're all okay. You can just click on one and it'll show you exactly where that via is, where that design violation is. So you can go back in your layout. I did go back and do some optimization in the layout. Here's another one where it says the through hole to SMD pad. So I've got an SMD pad here where I'm putting the 18 mega down, and I've got this via that I use for a test point. I've used these on several designs and never had an issue with this. It's saying that less than 2 millimeters is danger. Like mine is 0.23 millimeters, and it's fine. It's never had an issue. There's solder mask over this. Never had a problem with it. It says if it's too close, it can cause issues like solder wicking. Vias too close to pads are reported here. So this, it's not an issue on my board. So, and there's a couple other things. I've gone through and looked at all these. Some of them times it flags silk screen to pad. Oh, I've got a silk screen over a pad, and you're not supposed to do that. But it says, note, common practice is to remove silk screen overlapping pads causing character voids. So it's fine. Even if there is a silk screen on a pad, it's going to be fine for me. So plated through hole spacing. It's here. This one was, I can turn on the layers and show you, but plated drill holes. All that happened there is I had 24 instances of where I put a component pad over a pattern that I knew was okay. So you go through, you review them, you find out what looks okay and what does not. So that's the board, the PC board designed for manufacturing. And there's also the assembly. If you're going to do assembly, then you can do design for manufacturing there, where they'll tell you, oh, hey, this component's going to run into that component. So what you do, you have to load your BOM, and it's just like on the website when you're ordering boards. You open the BOM, you add the CPL component placement, which is the pick and place file, and then you process those. You just say next, and select each part. You need to select, how do you select the parts? 8 parts detected. Why did I not get those selected? Where's the point where I select? Where is it? Oh, there it is. Okay. I have to select them all. Okay. Didn't have to do that last time. So it'll give you a preview, and again here you can do a 2D and a 3D view. Here's a 2D view of all the components on there. You can do a 3D view, and you can see all the components, including these little feet that I added on here. So it's pretty neat. You do a save and close. Now you can run the DFM check for the component assembly, and it'll determine how manufacturable this is, or if there's any issues that come up. I did have issues, and I had to move these parts. I had to move them away from these header pins, so I had to do a complete relayout on my design to get those things away from it. Okay, so we're done. So looks like we did pretty good on here. Component spacing, everything's great. Component through holes. Again, I think this is this is just a thing where you've got these are like silk screen issues. They're not a concern. And component through holes, these were the ones where I added these header pins onto a another pattern for the 24 pin layout, and so it flagged it because, hey, you can't have this on top of that, but I'm intending to put that on top of that. So that's it. That's the DFM. So everything looks good there. So that's it. That's how you create a panelized custom version. The instructions they give are very confusing. They want you to create a individual instance of every schematic here and then match them up, and that's just a lot of work that's not necessary because you do a DRC on all these layouts ahead of time that you create modules of, and you don't need it. So that's it. Good luck, have fun with it, and we'll see you next time. Thanks.